Hello everybody, and welcome to my one video for homework 3. Pretty excited about that. But anyway, in this video I'm going to be solving this sort of problem with some mole fractions, and what's a better way to represent mole fractions. So in short, we usually represent mole fractions in terms of x1, x2, all the way through however many components there are in a system. And for maybe this system, we'll say that the fraction of water is 0.1, the fraction of propylene is 0.4, and the fraction of isopropanol is 0.5. And, it talks a little bit about the math behind that, but it's not really super important. Anyway, when we're working with some sort of a problem and we want to solve for the concentrations, which is pretty typical, a problem we might encounter when trying to solve it using Python is that if you have so many components, each component is going to have to be bounded between 0 and 1, right? Because you'll have like a set of simultaneous linear equations, and the thing maybe constraining the system is that water has to be between, every component has to have a mole fraction between 0 and 1. That's pretty sensible. I think it makes pretty intuitive sense to all of us. So anyway, it can be painful to enforce. You'll have to write a lot of constraint equations. And so my professor came up with a convenient way to overcome this using a variable transformation. You can just say that x at some value I, so maybe x1 is water, x2 is propylene, x3 is isopropanol. xi is just going to be e to the vi plus 1 plus the summation of all the vi's for I is less than n. So what it means by this is it's saying that for when I is less than the total number. So in this case where we have 3 components, that means that we have just 2 v's, v1 and v2. And that would be reflected in the summation down here. And so then, well, you're thinking, well, how do I get x3 for isopropanol? Well, the last x3 you just solve from taking 1 minus the summation of all the other x's. So it'd be 1 minus x1 plus x2 in parentheses. So let me go ahead and get out Paint, and we'll maybe try to represent this. Or I guess, actually no, I should get to the actual problem statement. We want to find a way to go from knowing x to getting v. So right now, if we know all the v's, we can get the x's, but in this problem, we just know the x's and we need to get the v's. So how do I get there? Well, that's what I'll try to do in Paint. So let's start out by maybe writing out what this equation should be. Or not what it should be, that's not exactly the best way to say it. But what is this equation saying for component 1? So we'll say for water. So for component 1, we are being told that e to the v1 over 1 plus e to the v1 plus e to the v2. That's what we're being told by this. And then similarly, we would have x2 and then e to the v2 up here. So that's sort of what this equation is telling us. Now, how do we turn this into something that is in terms of v? Or, something that basically says v1 equals yada yada yada. Because that's what we want to do. We want to go from knowing x to having v. Well, at some point, you can probably tell by this term up here, we're going to have to take the natural log. So let me go ahead and do that. I'll take the natural log of the whole thing. And what does that tell me? Well, I will then find that the natural log of x1 is just going to be equal to the natural log of e to the v1. Now this is all going to cancel, but stick with me for a second. Over the natural log of all this business down here. 1 plus e to the v1 plus e to the v2, which is just kind of the summation term down here. So looking at this, we can see this term up here will cancel down to just v1, so that's good. And we see this term down here. What can we do with that? Well, we can actually take that, and because it's a natural log divided by a natural log, we can turn that one into subtraction. So this natural log minus this natural log, and then we can just add it over to the other side. So if I go ahead and do that, I will get that v1 is equivalent to the natural log of x1, component 1, the mole fraction of component 1, and then that would be its subtraction, so then it would be plus the natural log of 1 plus e to the v1 plus e to the v2. So this is pretty cool, and so far we've got something kind of useful here. We have v1 all by itself, but then we have this natural log of e to the v1 plus e to the v2. And that's kind of causing us some issues. And so what I'm going to do is I'm going to take this term, just the second part, e to the v1 plus e to the v2, and I'm going to go ahead and define that as u. And then I'll come back up here and sort of restart, trying to solve and find something that represents u. And then I can substitute it back in, and hopefully everyone should be happy. Well, we know that xi is this, and that we know that x1 is this. We know there's something similar for x2, so let me go ahead and combine those two terms. I'll say that x1 plus x2, and I'm realizing I should probably be doing it up here. I apologize if any of what I've done has been cut off. I keep forgetting that that's a problem with the way my camera is. But I know that x1 plus x2 is going to be what? Well, it's going to have the same denominator, but it's going to have e to the v1 plus e to the v2 on top. So let me go ahead and write that out. We know it's e to the v1 plus e to the v2 over 1 plus e to the v1 plus e to the v2. So that's all sweet. I'm going to go ahead and you'll see that this is u, and so probably a lot of you are starting to see where I'm going with this. This down here is also u. I'm going to go ahead and, just to make it simpler to write, call that just x with no notation. And so then I can write this out as x is equivalent to u over 1 plus u. And so then if I go ahead and solve for u here, I will get what? U equals, let's see, you'd multiply the 1 plus u over, you get x times 1 plus u, so that would be x plus u times x. Subtract the u times x over, and you would be left with, you would take out the u, you'd be left with x over 1 minus x, I believe, right? Yeah, that looks correct, and if it's not correct, I'll figure it out later. So then, of course, x is just x1 plus x2. I just wrote that way to make it simpler to write. So now if I go ahead and write out this full formula for v1, now using the x's I've defined, I can find that v1 is going to be equivalent to the natural log of x1 plus the natural log of 1 plus, and then we have u, so that would just be x1 plus x2 over 1 minus x1 plus x2. I kind of wrote that out of order. That's funky. But yeah, this is a formula for v1. Now if I wanted to get this for v2, I would just change out this x1 with x2. And then that would be what v2 would be. But anyway, with this sort of figured out, how do I even know that this is correct? Well, before the start of the video, I went into Python and programmed this out real quick. So I imported numpy as np, and then I defined this function x2v. It's taking 3 inputs of x, so that would be 0.1, 0.4, and 0.5. And it's going to return v1, which is just what I just solved for, and then v2, which is the equivalent of what I just solved for v2, and then returns that. So I'll go ahead and run that. And let me run this real quick, and we'll see that it's telling me that v1 and v2 are going to be this negative 1.6 and negative 0.22 values. So that seems like it could be correct. Who knows? So then I'm coming down here, and I define a second function of v2x. So this takes two values, v1 and v2, and transforms it back into x1, x2, and x3. And that just uses the formula that I'm given in the problem statement, right? So I have this x1, x2, x3. Let me go ahead and run this. And now when I go ahead and run x1, x2, and x3, I should get these values I have down here. So, yeah. There it is. There is a small, very slight error down here, like to the negative 12th or something like that, but that's pretty minor. Everything else is just 0.4, 0.5. That's exactly what I put into it. So maybe if I come up here and I say, well, actually, I want v1 to be 0.9, and then I want v2 to be 0.07, maybe, and then v3, of course, is just going to be 0.03. Or x3. This is x1, x2, and x3. So just trying alternate values. Then, when I solve that, I will get two different values for v1 and v2. This time they're both positive. But I can just go ahead and plug those back in, and I will get pretty much exactly what I put in there initially, with there is some small error when you're talking about like to the negative 12th or something like that, but it is pretty much what I put in there. So that all looks pretty much correct. And with that, I have solved for given some x values. How do I get the v values? Well, that's just this down here. So with all that, I'd like to thank you very much for watching my video. I hope you learned something. I hope you find it helpful, and I hope you have a wonderful day. Bye-bye.